Good morning, students. Today we are coming with some numerical problems of the topics we have already discussed yesterday, right? So we were discussing errors in measurements, and we have said how absolute error is calculated, how the true value can be calculated, how percentage error can be calculated. And also we have said about the three ways how errors can be represented. Errors are represented in three ways. One is absolute error, and two is relative error, and three is relative percentage error. So related to those, so many problems there are described in the textbooks. You have to purchase a book also, you will see simple questions you will do. That's the way how we can develop the, right? What is your grip in physics? You have to do only simple problems, and also many problems you will choose that your brain can adjust with. So this is the way how you learn physics. So this is a question I wrote on the whiteboard like this. In an experiment, the length of an object is measured as 2.55 meter, 2.51 meter, 2.49 meter, 2.56 meter, 2.48 meter, and 2.58 meter. Find the actual length of the object. Second, absolute error in each observation and percentage error in the measurement. Actually, you see many times the observer did the experiment and found the data. The same length is found to be different in different times he took the observations like this. All the observations are different. How we can calculate the real value? Real value is true value, the actual length of the object. That can be obtained by taking the mean of those. So in this topic, you must understand that the true value of a measurement is equal to the mean value of the average of all the readings, observations made by the observer, right? So first observation, suppose A1, A2, A3, A4, A5, A6. 6 observations we have. So divided by 6, we are getting the A mean. Suppose A is small a is the right symbol of the physical quantity, right? Then A mean is equal to this one. In this case, every value 2.55 plus 2.51, 2.49 plus 2.56 plus 2.48 plus 2.58, the whole divided by 6. You are getting 2.5283. Right? The minimum number of what is called significant figures is 3. Therefore, we will make it into 3. 2.5. In all the values, we have the same number of significant digits, that is 3. So in the final result, also there must be at least 3 significant, and also a point of decimals, two places of decimal, right? So you got the real value or true value, it is written here, is equal to 2.53. How true value is calculated, that you understand. Now, absolute error in each observation. First observation is A1, second observation is A2, A3, A4, A5, etc. These are the observations. A1, A2. Mean value already you got, that is a true value. So the absolute error in the first observation is delta A1 is equal to A1, A mean minus A1. A mean is equal to 2.53 minus 2.55 is equal to this value. Like that, every observation you will find the absolute error, right? So first observation, this is delta A1, this is delta A2, delta A3, delta A4, delta A5, delta A6. All the values you have calculated this manner, right? Then mean absolute error is calculated. The mean absolute error is, you can write as equal to delta A mean or simply delta A also you can write. Am I correct? This is the correct. Then all the values of this absolute errors of each observation is taken, and now the mean of those is taken. That's called mean absolute error. You call it as delta A or delta A mean. That is not written here. Mean absolute error, you will write as equal to, this is, I'm writing here, this is delta A or delta A mean. Okay, right. Delta A mean is found as equal to all these values added divided by 6. You got 0.0335 meter. Okay. 0.035 meter. This is equal to delta A, or sometimes we can say delta A may not. Now, percentage error in the calculation is equal to mean absolute error or absolute error generally divided by true value into 100. Absolute error is this value have found now, divided by 2.53, that is the true value, into 100, that is equal to 1.383%. Right? The proper significant digits when you write, that is equal to plus or minus 1.38%. This is the percentage error in the measurement. So this is this question about, and I am writing now another question. That question is also very simple question, because in physics we have to do, in the beginning days we have to do only very simple questions. As many as simple questions you can collect and do better. Right? So in physics you must be always with the physics. Right? When you walk, when you think, when you laugh, when you smile, every time you have to think about physics. Then only you can reach to a position that you expect in your life. Right? If you learn some theory by heart, and if you believe that you have done everything in physics, you studied everything in physics, you are the biggest fool in the world. It is not that way. Every time you must be with the physics. Love physics, and also do as many as numerical problems after learning the theory. This is the thing. Teacher cannot do a number of questions, 1 or 2 or 3 or 1, 2, 3, 4 or 5 questions the teacher may be able to do, right? So at that time you must be with physics. Next question I am writing is question 2. Question 2. In an experiment, initial and final temperature. Initial and final temperature of water are measured as 16 plus or minus 0.5 and 41 plus or minus 0.1 degrees centigrade. Find the rise in temperature. Find the rise in temperature. Rise in temperature. This is the question, right? So this is the initial temperature and this is the final temperature. Now we see these digits, 16 and 41 shows the real values. Real value of the measurement. Initial temperature is 16, the real value, true value, and the final temperature is 41. But when you observe it, some variation can come there. That is because of so many reasons that you have discussed. That may be due to instrument, that may be due to person, that may be due to imperfection, right? That may be due to what is called external causes, or the carelessness of the observer. Many reasons are there why errors can happen. So this is the real value, and this is observed value. Observed value can be plus 0.5 or minus 0.5. Yes, that we don't know. Okay, it's also like this. This is absolute error in the measurement. This plus or minus that you see is the absolute error in the measurement. Initial temperature absolute error is this much, and final temperature is this much. So we have to find the difference in temperature. Find the difference in temperature. First of all, the real values are the difference is taken, and the absolute rates are added. Already we have said in the combination of rates how we add to x is equal to a plus b. We have seen that delta x we had to find out. In that case, what you have done, plus or minus delta a plus or minus delta b. In the same way, the real values only the difference will be taken between real values, and the absolute rates are always added up. So in this case, what we can write is There is rise in temperature, temperature delta theta is equal to theta 2 minus theta 1. That is equal to 41 point, 41 plus 0 plus or minus 0.1 minus 16 plus or minus 0.5, right? This is equal to real values. Between real values only the difference is taken. Again, this must be added or plus or minus 0.1 plus 0.5. This is the condition. Absolute rates are always added and will be written with the difference as plus or minus, right? So this we are getting as equal to 25 plus or minus. This is added. That is equal to plus or minus 0.6 degree centigrade. This is how we can do this question, right? So I'm writing another question. That is question number 3. Question number 3. There also I'm writing the errors committed. The errors committed. To write all the questions and go and explain, it takes time, right? There are so many factors why we are not able to do many questions on the board. So in online classes, this is a very big problem. So if I don't write the questions, how can you see the question and understand the matter there? So error committed in the measurement of potential difference. I write PD here. Potential difference in electricity, potential difference and electric current are their common terms. Across a conductor, and current, potential difference across conductor and current are 5%, 5% and 2%. This 5% and 2% when is written means, remember this is percentage error, right? Relative percentage error, right? What will be the percentage error in the calculation? What will be the percentage error in the calculation? That is a question, right? Calculation of resistance. So actually we are going to calculate resistance using these values, having percentage errors in the potential difference of 5% and the current as 2%. When you calculate the value of resistance, what will be the total percentage error in the calculation? This is the question. So we know that R is equal to V by I. Everybody knows that. Capital R is equal to V by I. It is a division. Yeah, this equation is a division. We have to calculate the percentage error in the calculation of R. So first to find the percentage error, first of all, we have to calculate relative error. Relative error in R is equal to delta R divided by capital. Delta R divided by capital. That is equal to, we have already seen in division how we did it. That is delta relative error in potential difference plus